This is section 9.2, and we're going to focus on polar equations, doing a little bit of conversion and recognizing what these equations look like when graphed. So here's a nice little chart that would be good reference. So polar equations that are in the form of r equals a plus or minus a cosine theta or a sine theta, where a is positive. So this is a typical graph, cardioid. Remember, like that kind of thing makes you think like a heart. So cardioid looks like that. Now, a limicon is when you have a number here that is different than the a. So a plus or minus b cosine theta, where a is greater than b. And so that gives you a limicon without an inner loop. So this is what that looks like. If a is less than b, you get a limicon with an inner loop so that it loops like that. A lemniscate is r squared equals a squared cosine 2 theta, or sine theta, and you get petals, kind of, like a propeller almost. Then you could have a rose with 3 petals, that's 3 theta, when it's sine and a is greater than 0. And then if you have a sine 2 theta, you can have 4 petals, and it can go on. You could have lots of different options, but those should give you a start to seeing those. So down here we have kind of some examples. Identify and graph the equation r equals 3. Well, we want to convert that to rectangular. So our strategy will be to square both sides. When we do that, we get r squared equals 9. And we need to remember that r squared is equal to x squared plus y squared. That's important. So we'll substitute that in. Now we have our rectangular equation. The graph of r equals 3 is a circle with the center at the pole and a radius of 3. So there we go. If we had theta equals pi over 3, that's different. We're given an angle. So to do that, you find the tangent of both sides. Tan theta equals tan pi over 3. Well, from our trig, tan of pi over 3 is square root of 3. And we know that we learned in the last section, tan theta is y over x. So now we've got it in rectangular. We'll multiply this x over here, and we'll get y equals the square root of 3x. All right, let's look at this one, identifying and graphing a polar equation. So to transform this polar equation into rectangular coordinates, multiply both sides by r, because we need r squared there. So we have r squared equals negative 2r cosine theta. So we need to remember 2 things. R squared is x squared plus y squared, and x is r cosine theta. So when we make those substitutions, we now have x squared plus y squared equals negative 2x. So if you bring the negative 2x to the other side, you now have x squared plus 2x plus y squared equals 0. We're going to look at the x parts and complete the square on those. Remember, half of 2 is 1, 1 squared is 1, so you're adding 1 there. You have to add it to the other side. Then we'll make, this is a perfect square now. It's x plus 1 squared plus y squared equals 1. That is the rectangular equation. So it's a circle with the center at negative 1, 0, and an r, a radius of 1. And so it would be there. We'll also talk about how to graph them on your calculator. But I think that should get us started to look at our problems. You may have this available to you as you go through your problems, because that will be helpful for some of your questions. So let's go to the problem set. We like to start out with some language. An equation whose variables are polar coordinates is called a, and you get to choose from these items. It is a polar equation. Rose curves are characterized by equations of the form r equals a cosine n theta or a sine n theta, where a is not equal to 0 and N is even. The rose has 2 N petals, and if N is odd, the rose has N petals. So using that N that's in your original equation, or you multiply it by 2 if it is even. So you would fill those in. Determine whether this is true or false. The graph of a cardioid passes through the pole. That is true. Remember, let's look back here. The cardioid goes through the pole. That's what makes it different than a limicon. Looks very much like it, but the limicon doesn't necessarily go through the pole. All right. Transform this polar equation to rectangular. So we start out, we have r equals 12. We're going to square both sides. We get r squared is 144. We remember r squared is x squared plus y squared, and we make that substitution. So that right there is the standard in rectangular form. So we'll put that there. What is the graph of the equation? That's a circle. The center is at 0, 0 because you don't have x plus 1 or y plus 5, anything. It's x squared plus y squared. So that's 0, 0. Take the square root of 144 and you get the radius, which is 12. And then you, these you can't see very well, but that's the only one that is the circle, and it'll show a radius of 12 in your problem. Number 5, transform this to rectangular. We've got theta equals pi over 4. We did one of those in our notes. So you find the tan of both sides. So tan theta equals tan pi over 4. Tan theta is y over x. Tan pi over 4 is 1. From trig, we should remember that. So we have y over x equals 1. Y equals x is our equation, which goes there. That's a line that goes through quadrants 1 and 3. I want to make sure that said that right. And so y equals x is that line that goes through the origin or the pole and goes through those two quadrants. Number 6, we've got r equals 12 cosine theta. We're going to multiply both sides by r. We get r squared is 12 r cosine theta. These are the two things we need to remember. So we substitute those things. X squared plus y squared equals 12. Now we just have x. We bring the 12x over. We're going to complete the square on this. And remember, completing the square is you take half of this, so that's 6, and you square it. So you add 36 there, but you have to add it over here as well. Then you write that as a single factor. This is a perfect square. That's x minus 6 squared. You know this number because it's always what half of this was. So there is our equation that goes there. That is a circle with the center at 6, 0, and a radius of 6. And we just can't see these very well, but you should be able to see that that's a circle and that you're at -6, 0, and a radius of 6. Number 7, identify and graph r equals 5 plus 5 sine theta. All right, so this is where we want to pull up our calculator. So let me get my calculator up. Okay, so I've got this up now, and we want to be sure that you understand how to do this. So the first thing is you want to go to mode on your calculator, and over here you want to go down where we've got it on function for most everything we do. We want to go over to polar. So I'm going to go down and go over to polar and hit enter. So now I've got it on polar. So I'm going to second quit out of that. Now when I go to y equals, I've got r equals. And so we are doing 5 plus 5 sine theta. So 5 plus 5 sine. When you hit your variable key now, you will get the theta. So that's what we're doing. Let's do, I'm not sure what window we need to hit. Let's go ahead and just hit graph, see what we get. Well, we got something that works for us, I believe. So my window, I'm not sure, that looks like 2 pi, 0 and 2 pi. Let me do a zoom 6 and see if we still have a good, okay, yeah, that's good. That's a normal window. So we can see that it is this guy down here. All right, and it is a cardioid. It goes through the pole. All right, so let's see if we can do another one similar to that. Let me move that for a minute. All right, and then I showed you putting it in the calculator there. All right, 6 plus 12 sine theta. So let's go do that one. Let me bring my calculator back up. And we'll go back to y equals and clear that one. And we've got 6 plus 12 sine theta. Close that, and I'm going to hit graph. Now, we're not seeing it all, and I have posted right here, press zoom 0 to see it. So let's do zoom 0, which is zoom fit. And then you can see the whole thing. So keep note of that. And that one is right here. And that is a Limicon with an inner loop. Okay? So the zoom 6 worked to get part of it, but zoom 0 is going to let you see more. All right, number 9. R equals 8 cosine 4 theta. Let's go do that one together over here. Go to y equals. We'll clear, and we will do 8 cosine, and then 4 theta, and close, and let's hit graph. This one, let's do zoom 6. So we get back to there. We didn't need that other window. So zoom 6 gave me that. So how many petals do I have? I have 8. And so a rose with 8 petals. And remember, it was 2. When this is an even number, it has 2 end petals. So that's 8. And we saw that right there. Okay. All right. Number 10. R equals 9 sine 5 theta. And remember, when it's odd, you're going to have that many petals. And look, we've got 5 petals. You would do it the same way when you go in and you would pick this graph and you would get that. So just a taste of graphing polar on your calculator and then converting when given some equations. I think that should get you through section 9.2.